Pipeline Studio is about understanding your workflow and knowing when it's running smoothly. System alignment. What appears as instability at the edge, emergence in artifacts, and containment in the pipeline are not separate events. They are the same system observed at different distances. When time is compressed, systems are forced to resolve behavior immediately. What was once distributed across duration collapses into a single decision point. That collapse creates the edge. The edge is not a location in code or tooling. It is a condition. A moment where assumptions no longer have time to negotiate. At that edge, interactions that were previously invisible become exposed. Buffers, decoders, caches, execution order and presentation layers are no longer amortized. They collide. What emerges from that collision is volatility, not chaos, not failure, but variability that cannot be predicted from any single component in isolation. Seen up close, this volatility looks like an artifact, a frozen frame, a delayed onset, a brief mismatch between expectation and motion. Seen from farther away, it looks like emergence, behavior produced by interaction rather than defect. Seen farther still, it demands a response from the pipeline. These perspectives are not in conflict. They are stacked. Compression creates the edge. The edge exposes interaction. Interaction produces emergence. Emergence requires containment. When viewed individually, each layer invites misinterpretation. The edge looks like a mistake. Artifacts look like errors. Containment looks like compromise. When viewed together, they form a complete cycle. The edge is where long-form assumptions stop being free. Emergence is what replaces those assumptions under pressure. The pipeline is what carries the system forward without collapse. Nothing in this sequence contradicts stability. It redefines where stability must be applied. In long-form systems, stability is implicit. Duration absorbs variation. Time forgives small misalignments. In microtime systems, stability must be explicit. There is no surplus time. Every decision occupies a visible percentage of the experience. This is why edge behavior feels disproportionate. A single unstable frame in a 6-second clip is not minor. It is structural. The system is not malfunctioning. It is responding instantly. Understanding this alignment removes confusion. The pipeline is no longer judged by whether instability exists. It is judged by how instability is handled once it appears. Upstream stages define intent. They preserve structure. They assume continuity. Downstream stages stabilize perception. They bound volatility. They apply resolution where the viewer encounters it. This division of responsibility is not arbitrary. It is the only configuration that survives compression without escalating cost. When these roles are misaligned, systems become brittle. They overcorrect. They accumulate complexity. They chase purity where leverage is lowest. When they are aligned, the system remains calm under pressure. Edge behavior becomes contextual rather than alarming. Artifacts become signals rather than accusations. Containment becomes discipline rather than apology. This alignment does not eliminate the edge. It makes the edge intelligible. And once the system is understood as a whole, its behavior stops looking contradictory. It looks inevitable. Inevitability changes posture. Once the system is seen clearly, urgency fades. There is nothing to chase, nothing to correct in panic. The pipeline stops reacting and starts holding. This is where confidence comes from, not from the absence of instability, but from the consistency of response when instability appears. The system does not flinch. It does not escalate. It continues. That continuity is what the viewer trusts, even if they never consciously notice why. And that trust is the real output of alignment. Alignment is what allows systems to endure pressure without distortion. Operational closure. Once edge instability is understood, the system changes its posture, not its tools, not its components, its expectations. The mistake most systems make is not technical, it is interpretive. They see instability and assume something has gone wrong. They treat emergence as failure. They respond with urgency instead of clarity. That urgency is where damage begins. Pipelines that misclassify edge behavior escalate unnecessarily. They introduce safeguards where none are required. They reinforce upstream stages that were never meant to solve microtime behavior. Complexity grows, costs accumulate, confidence erodes, all while the original condition remains. Correct classification collapses this entire problem. When instability is recognized as an expected property of compression, there is nothing to fix upstream. There is only something to manage downstream. This recenters responsibility. The pipeline is no longer evaluated on whether friction exists. It is evaluated on whether friction is contained without spectacle. Viewers do not demand perfection. They demand continuity. They forgive texture. They tolerate variation. What they reject is collapse, hesitation, and visible struggle. A pipeline that absorbs instability cleanly never appears to struggle. It continues. That continuation is the signal. It tells the viewer that the system is intact, even when behavior at the edge fluctuates. This is why containment is not compromise. It is control applied at the correct layer. Stability is not the absence of volatility. It is the presence of a reliable response. When systems attempt to eliminate every edge condition, they become fragile. They overfit. They lose the ability to adapt when conditions change. When systems accept the edge and design for it, they remain flexible. They scale without accumulating invisible debt. They move faster without breaking trust. This is the difference between reactive pipelines and resilient ones. Reactive pipelines fight symptoms. Resilient pipelines manage conditions. The goal is not to prevent every irregularity. The goal is to ensure that irregularities never dominate the experience. Once this is understood, the pipeline simplifies. Decisions become clearer. Responsibilities become cleaner. Energy is spent where it matters. Upstream defines intent. Downstream stabilizes perception. The edge is acknowledged, not feared. There is no drama in this model, no emergency posture, no constant correction, just discipline. And that discipline is what allows systems to operate under pressure without turning instability into a crisis. The pipeline does not promise perfection, it promises continuity. That promise is kept not by avoiding the edge, but by knowing exactly how to hold it. Holding the edge is not a passive act. It requires the pipeline to know where responsibility begins and where it ends. It requires restraint as much as capability. Most failures at scale do not come from missing tools. They come from misplaced effort. Energy spent upstream chasing edge purity produces diminishing returns. Energy spent downstream shaping perception produces stability the viewer can actually feel. This is the economics of resilience. A pipeline that understands its own boundaries does less work, not more. It avoids redundant safeguards. It avoids constant escalation. It avoids treating every anomaly as a threat. Instead, it normalizes response. When instability appears, the system does not hesitate. It does not argue internally about fault. It applies the same bounded treatment every time. That consistency is what prevents edge behavior from accumulating into narrative failure. The experience holds. This is why operational closure matters. Not as a rule set, not as doctrine, but as a shared understanding of how the system behaves under pressure. Once that understanding is in place, the pipeline no longer needs vigilance. It needs discipline. And discipline is repeatable. This concludes this session. Let what you've heard settle before continuing.